Hi, it's Bob here for racecarbook.com, airdensityonline.com. We're going to demonstrate using the Pro-Calc's fuel injection jetting calculator to select a jetting profile for a typical mountain motor used in, say, tractor pulling or possible mud racing or something like that. First thing we're going to do is start out with a new baseline profile and see what we have. What we have is a 620 cubic inch, very expensive mountain motor with very high flowing cylinder heads, a lot of cam timing, very large valves. Now I don't see anything in there that's close to it, so let's go to my information and see what I have. This is a normally aspirated engine, so I'm going to go here to normally aspirated. Here's my list of normally aspirated engines. I see a lot of sprint car engines. 475, it looks like that's the largest that we have that's listed at the time of this video. And that's the torque peak, and that is without a high-speed bypass, which is where we want to start. So we're going to go ahead and load that starting out. I'm going to select that from the list. Okay, so now we have a profile beginning. Unfortunately, this is for a 475 motor, which is a lot smaller. So I'm going to go ahead and change this to 620. And this is at the torque peak setting prior to you opening a high speed. So I'm going to come down here, I'm going to move that up to 620 cubic inches. Now this has very high flowing cylinder heads, intake valves over 2.5 inches, CNC machine ports. So I'm going to put the volumetric efficiency from, say, a database that we've gotten with this at 105%, which would be typically attainable. Okay, now we have no idea what our fuel pump is going to be at this point, so let's go to our fuel pump list and let's select a fuel pump for this. Okay, I'm not sure where we're going to be at, but we're going to need some somewhat of a significant fuel pump volume, so I'm going to go with a Waterman. Sprint, and that's a 7 gallon a minute pump. So we're going to put 7 gallons a minute. Scanning up here, let's look at some other fuel pump sizes from some other manufacturers. Ron's has got one a little bit smaller than that, and then they've got a twin gear that's a little bit bigger. Kinsler has one that's just slightly smaller than that. The KW series, and Hilborn has got around that size as well, a little bit more, a little bit less. We'll stick with the 7 gallon a minute pump that we had selected. Again, this is a 4,000 pump RPM, 8,000 engine RPM combination. This would be applicable in applications where you're running the fuel pump at 1/2 engine speed. The engine speed, this would be an 8,000 RPM engine speed rating for that fuel pump. Okay, the number of cylinders is 8. We're going to look at 1 nozzle per cylinder at this time. We have no idea what the main is going to be. I'm just going to put 100 in there to start out with. Okay. I'm going to leave my target RPM at 5,000 because this engine torque peak is probably going to be around 5,000, maybe 5,500, but somewhere in that range. In fact, let's go ahead and put it at 5,500 RPM to keep it a safe value. That's going to subsequently determine the high-speed opening point. Okay, this is a track, typically 80 degrees temperature, 30% humidity, and 29.9 would be a typical barometer. This would be a typical near a coast tractor pulling location. I have no idea what nozzles to put in this. The 34s may or may not be applicable, but at this point it's immaterial. We'll use the calculator to determine what we need. Go ahead and create my baseline profile. Okay, this has got a 491. That's interesting. That would be a pretty good number to start out with. Fascinating. Let's go up here to the air-fuel ratio calculator. Okay, I have to re-enter my weather. 80, 30, and 29.9. Get air to fuel ratio. Okay, that's showing 4.9 air to fuel ratio. The 5,500 RPM pressure 76. That's actually pretty good. And that's for a stroke in the dark. That runs pretty good. What we're going to do now is switch over to jetting calc. Okay, and I'm going to go jetting from pressure. Okay, I'm going to go down. All right, now 491 came out of my baseline, which was a pretty good number, and the 161 is the pressure that was determined without a high-speed bypass. Let's play around with that a little bit. We end up coming back to 491, but I'm going to say that I want this to be a lot fatter in tractor pulling because this thing's going to be under an enormous load for a 15-second pull or longer. So let's change that down to 4.6. Okay, I go over here and get the jetting. For the same pressure, that's asking me for a 35 nozzle and a 97 for the main bypass. Just as an illustration. Now, the other information that's available on this page, for those who tune by total engine jet area, here's my engine jet area, total area, and here's my total jetting area, including the bypass. And then the percent fuel to the motor is 51%. That's a good target. 50 to 75% is a good target. Okay, here's the weather computations for the air density values that we entered. The hotter weather and humidity gave me a density altitude of about 1,600 feet, which is a 95% air density. Okay, I'm going to go back to baseline profiles. That has not maintained the values when we changed it in that air-fuel ratio calculator. We're back to our edit baseline profile. We're back to the numbers that we selected. If we were off, we could make adjustments to the main bypass or the nozzles until we got an air-to-fuel ratio somewhere around 4.9 to 1. Well, what I'm going to do, knowing that this is a little on the lean side for tractor pulling, is I'm going to richen this a little bit, and I'm going to go to a 95. And that's about 4.6. That probably would be a more reasonable number in tractor pulling, whether you're under enormous load, especially an engine this big. On the other hand, if you have a really good cooling system, you may want to get it back up to that 4.9 to 1 air-to-fuel ratio. Okay, what we're going to do now is look at setting up the high speed. So what I'm going to do is duplicate this combination, and I'm going to change this to horsepower peak. And typically, if this is a real high flowing cylinder head, it's probably the volumetric efficiency might be around 95%. So I'm going to put in 95 in there. I'm going to leave everything else the same because we don't know how big of a high speed to put in this. So I'm going to go ahead and create baseline profile. Now that drops my air-to-fuel ratio down to a 4.2. That's pretty fat without a high speed. So if you don't have a high speed, this analysis is telling you that you're starting out at 4.6, and as the engine RPMs climb, it's going to go down to 4.2. So what we're going to do now is we're going to go to the air-fuel ratio calculator. I'm going to select my horsepower peak combination, get air-to-fuel ratio. Okay. Confirm that our same weather is in there. Okay, the same weather is in there, going back up. Okay, now we're at 421. Want to look into, explore looking, leaning that down. Now, what's interesting is 5,500 RPM, the pressure without any high speed is 84 psi. That, if you want the high speed poppet to open at 5,500 RPM, you would set that to 84 psi. Okay, going down. Let's now explore putting a high speed in this. So I'm going to put a 70 in there. As it just picking something. And that's getting me to about a 534 air-to-fuel ratio. That's a little, might possibly be a little on the lean side for a tractor puller. So let's take 5 thousandths out of that and put that at 65. Get air-to-fuel ratio. And we're at about 519. That would be a pretty safe number and making lots of power. Go back to the baseline profile. Put the 65 back in there. And there you have it. You've got your torque peak air-to-fuel ratio without a high speed, and you've got your horsepower peak air-to-fuel ratio with a high speed. We're going to do one more thing. Let's examine everything looks correct that's in there. I'm going to go immediately to the air-fuel ratio calculator. Get air-to-fuel ratio. Fuel pressure gets up to 118 with the high speed. I'm going to switch over to jetting calc. I'm just going to jump to the main bypass, and it'll pull all of the data out from the baseline profiles. Get main bypass. Okay, that's showing me the pressure with the high speed closed of 84 psi. That's the opening point for the high speed poppet at 5500. And then that flat lines and creeps up to 118 psi with the high speed open. So that would be the typical performance with the high speed poppet in there. And that's a pretty reasonable number. And again, that's showing a main bypass of 095. 34 thousandths nozzles and a 65 thousandths high speed. Thank you for your time.